Hello everyone. It's so exciting that we are getting into the seventh test here. I'm assuming that everyone here is aware of what we are doing, but in case you are new, basically what we're doing here in this video series is that we are going through the GRE Big Book Test. There are 27 tests, and for Quant, in each test, there are two sections. So essentially, there are going to be 54 videos that we are going to shoot in this video series, and we are just starting with the seventh test today. So other six tests, basically 12 videos, are already published. You can find the link of all previous videos in the description box. Uh, how do we what do I recommend you do when you're watching these videos? I recommend that you pause the video and solve those questions and then go through the explanation so that you're not just watching the videos, but you're actually getting involved with the concepts and the material. And obviously, you need to keep an error log so that you understand what type of mistakes you're doing, whether those are conceptual mistakes or mistakes that are sort of behavioral silly mistakes and things like that. Okay, so that's the best way to use this video series, and on that note, I will see you right inside the test now. All right, so let's get going. As you can see, this is test 7 section 3, 30 minutes, 30 questions. Okay, let's look at the first question. Quantitative comparison, the average arithmetic mean of 10, 20 and 30, and arithmetic, we have to compare that with average arithmetic mean of 12, 20 and 28. Okay, so you could do it multiple ways. Of course, you can find out the arithmetic mean. Basically, you add these numbers. What do you get? 10 plus 20 plus 30, so you get 60. 60, how many numbers are there? 3. So 6 divided by 3, you get 20 as the answer here. Same thing here, 12 plus 20 plus 28, again you're going to get 60 divided by 3 is equal to 20. So if you just calculate the arithmetic mean, you will find that both of them are the same number. So answer is going to be C. But the trick here is a faster way. An effective test taker, how he should think about it is, let me just do that in another color. See, the middle number is the same, right? And they are anyway put in ascending order, right? And this number and this number, so difference here is 10, difference here is 10. So that means the other two numbers are equidistant. The midpoint of that obviously is going to land at 20. So essentially this is going to be, without doing any calculation, you can reason that the average arithmetic mean is going to be 20 here. Same thing here. The numbers are different. The middle number is same, but the other numbers are different. So here the difference is 8. Here also the difference is 8. The midpoint of, again, midpoint of 12 and 28 is going to land on 20. So arithmetic mean here is also going to be 20, right? So it could have been other random big numbers also. In that case, you would take longer to calculate by method 1. Method 2 helps you when the numbers are awkward. Okay. But either way you do it, this is the answer is going to be C. Okay. Let's move on. Question number 2, x square and y square I need to compare. Triangle, okay, x is here, y is here. All right, and I know that it's a right angle triangle. Okay, so typical Pythagorean triangle here. So I know, what can I know from this figure? I can know that x square plus w square is equal to y square. Okay, right, and this is, w is some number, so this is going to have some value, some positive value, right? So that means x square plus something is y square. X square plus something is y square, correct? So then compare x square and y square, then you will realize that if x square plus something is y square, x square has to be smaller. That means y square has to be bigger. Answer is going to be answer choice B. Okay, question 3, x is going to be minus 7. All right, so 7 minus x, so that would be 7 minus minus 7, so that's going to be 14. Okay, be careful with the minus sign. And x minus 7, that means minus 7 minus 7, so this is going to be minus 14, right? You need to be careful with the signs because it's essentially the same operation, similar operation we are doing, uh, one in one direction, the other in other direction, right? So this is all negative numbers, and this is all positive numbers, minus minus positive, right? So one is giving you 14, the other is giving minus 14. answer choice A. 14 is greater than minus 14. Okay. Question 4, root 60 by root 15. Okay, because both of them are under root, I can also put them under root together like this. So that means, and let me do this first. So that is 60 by 15 is 4. So essentially I'm talking about root 4 here. Okay, so this is root 4 and this is 4. Root 4 is going to be 2. I mean, if you want to do that, but it could have been any other number also, because these are positive numbers. The root number is going to be smaller. Positive numbers are also greater than 1, right? So this number is going to be smaller, this number is going to be bigger, so answer is going to be answer choice B. Okay, if this number was not, and we have seen that in previous several times actually, and I've made this comment in other videos also, is that when the root is uh, so let's say this is 0. Okay, on number line this is 1. Whenever we are talking about these numbers that are greater than positive 1, the root of that is also greater than positive 1. Okay, and okay, let me just do explain it elaborately here. 0, 1, let's say 4. Okay, and root of 4 is 2, right? So that comes towards 1. If x is 4, root of x tries to go towards 1. Same thing happens here, right? If x is here, let's say uh, 0.36. Okay, the root of that is 0.6, right? 0.6 into 0.6 is 0.36. Okay, the root, this is x, this is root x. Sorry, so this is right, so this is x and this is root x. The root of x tries to go towards 1, but in this case it's increasing. Okay, so you need to keep that in mind. You can't really compare x and root x like that without knowing whether x is greater than 1 or less than 1. Okay, they behave differently when it comes to the comparison between x and root x. They are all positive numbers, but depending on whether x is on which side of 1 x is lying, whether it is less than 1 or greater than 1, the behavior of root x changes, right? So here it's not all that complicated, the numbers are easy, but this is a concept that we have seen tested several times on these tests. Okay, uh, fine. So let's move to question 5. X raised to 4 minus y raised to 4, I need to compare with 0. All right, uh, and I have this information given. All right, one thing that comes to my mind is I can add these two, right? That will give me, this will get cancelled, that will give me something x square, but it doesn't tell me anything about y square, right? I mean, I can find out something about y square, but the point is I don't need y square, I need y raised to 4. So it's a very long way of uh, going about it, doing the calculations and all that. But can I do something logically here, right? Look at it this way. These are all square terms and this is raised to 4. So can I say x square is 1, sorry, x square is a and y square is b. In that case it would be a plus b is equal to 81, a minus b is equal to 0, right? And I will have to express this also in terms of a and b. There I am going to use the formula. If x square is a, then x raised to 4 is going to be a square. Same thing, this is going to be y square, and now I'm going to use the formula of a square minus b square is a plus b into a minus b. Okay. So if I look at it this way, these two values are already given to me. This is a plus b and this is a minus b, so I get 81 into 0 is 0, right? So just little bit of imagination and I'm able to do that. So I get 0 here, I need to compare that with another 0. Both quantities are same, answer choice C. Let's look at question 6. The perimeter of square ABCD, that is, this is a square ABCD. Let's say, so these are all 90 degrees. Okay, perimeter. I need to know the side. All right. I don't. Let's see what information I have. The diameter of inscribed circle is 2. So this is 2 diameter. Okay, always be careful whether it's a diameter or radius. Radius is 1, diameter is 2. This side is also going to be 2. Why? Because these are all 90 degrees, right? The radius, this side of the square is going to be tangent to the circle, right? That's why it is inscribed. Okay. So this is also a 90 90 90 90 rectangle, so parallel sides are going to be equal, so this is going to be 2, this is also going to be 2 2 on all sides. Okay, because that's a square. So the perimeter is going to be 8, right? 2 plus 2 plus 2 plus 2, and here I have 2 pi, so 2 pi is going to be 2 into 3.14 for simplicity, so 6.28. So I have 6.28 on this side, 8 on this side. Answer is going to be answer choice A. Okay, x is greater than 1. Okay, let's pick a number. X is equal to 2. Okay, let's calculate this. X square, if x is equal to 2, what do I get for x square? I get 2 raised to 2, that's 4. For x square also I get 2 raised to 2 as 4. I get answer as C. But that was only one case of x is equal to. If I say x is equal to 3, okay, let me do that in another color. Let's say if x is equal to 3, I get 2 raised to 3, so that is 8, and 3 raised to 2, so that is 9. So here I'm getting answer as B. I don't have to do any more cases because two valid cases I'm getting two different answers. That means the answer cannot be determined. Answer choice D. Okay, let's look at question 8. The price of an article of clothing was reduced from $25 to $20. Okay, it was 25 earlier, now it is 20. The reduced price of the article was then increased by X percent to return it to $25. So increased by X percent. Okay, that means uh, how much did I increase it by? Let's do it in absolute sense first. I increase it by, I brought it back to 25. I increased it by $5. Okay, that is what percent increase when the base was 20. Correct. So that is, let's multiply everything by 5. You will get 100 here, you will get 25 here. So basically 25%. 25% was added to the base of 20. 25% of 20 is 5. 5 was added to the base of 20 to bring the value, return the value as they say to $25. Okay, so the percent here was 25%. Okay, and that needs to be compared to 20. Answer is going to be answer choice A. Okay, it's a fairly straightforward question, just that this 25 is dollar, whereas the answer that they are asking is 25%. So there may be some confusion here for some students, but if you just go conceptually, I think it's a fairly straightforward question. Okay, let's move on. Question 9. X and 14 I need to compare. Okay, x and 14. All right, where is x? X is here. What do I know? I know that these L1 and L2 are parallel. That means L1 and L2 are parallel. Okay, basically what it means is that this triangle and this triangle are similar triangles, right? Right, these are parallel, so these angles are going to be similar angles, and this angle is constant, same in both triangles. Okay, so essentially angle, 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 three angles same, those are similar triangles. That means, okay, now let me just remove this cat so that you can see what that means is that let's say if this was K, whatever is the ratio between this and this, 6 by 8 will be the same ratio between 6 plus a, this length, and x. Okay, but what is K? I am interested in finding x. I need to know K. How far is that line? Okay, if this is to be compared with 14, it is possible that this is 14. I mean, I just move it appropriately enough that x is 14, or maybe I move it very far, right? Maybe like 100 units away. Okay, 100 units away. This number is going to be much, much bigger. Or maybe I just move it 0.1 inch away. This is, let's say, 0.1. Okay, then this is going to be something, let's say, 8 point something. Okay, approximately. So I don't really know whether x is uh, greater than 14 or not. Right, it could be 14, it could be greater than 14, it could be less than 14, because I don't have any control on this K. So I can't really determine. Answer choice D. Okay, question 10. 4.1 plus 1 by 3, 5 minus 1, sorry, 5.1 minus 2 by 3. Okay, there are two ways to do this. Again, you can obviously do it the decimal way. So you can do 4.1 plus, what is 1 by 1.3? Let's say 0.33. Okay, So this you are going to get 4.43. Okay, or 5.10 minus 2 by 3, 2 by 3 is 0.66, right? If you do that, or 67, let's do. Okay, because we are rounding it. This also be rounded off, right? So this is getting rounded down. This is going to round it up. So what do I get here? What do I get here? And I'm obviously going to get the same number here, 7, 4, right? Uh, Correct, 4.4. Okay, I'm getting the same number. Okay, there's another logical way of doing this. This is one method. A logical way is compare these two numbers. Correct? How far are they? They are 1 unit away, 4.1 and 5.1. Okay, so I'm starting from here and I go one third adding. Okay, so I go one third here versus I start from here and go on the other side two third. Okay, and the distance between them is 1 unit anyway. So isn't one third plus two third giving me 1? Obviously there is giving me 1. Basically what that means is that I will land up at the same point because the total distance I have to cover is 1 unit. From here I am covering one third, here I am covering two third. I have to land at one third point from 4.14, right? That point 1 doesn't really matter here. Okay, it could have been 4.8963, this could have been 5.8963. So long as they are, the difference between them is 1, right? uh, I would land at this same point. Okay, so essentially this is answer choice C. Okay, let's look at 11. Question 11, y is not equal to 5. All right, I can pick any number. Let's say y is equal to 0. Okay, in that case I get this into this. If y is equal to 0, 5 minus 0 is 5. uh, 0 minus 5 is minus 5. So that's going to be a negative number to be compared with A. I get answer as B. Okay, let's say y is equal to 10. What do I get? 5 minus y is minus 5. 5 minus 10 is minus 5, and 10 minus 5 is 5. I get the same number, some negative number, right? Compare that with 0, I get B again. Okay, every time I'll get B. The logic behind that is, look at this. That's the whole trick here. Okay, 5 minus y and y minus 5. Okay, they are opposites of each other. This is, when you multiply 5 minus y by minus 1, you get y minus 5. Correct? So they are negatives of each other. What that means is that one of them is positive, one of them is negative. They cannot be 0. Why? Because y is not equal to 5. In that case, they would have been 0. That case is eliminated. So one is a positive quantity, the other one is a negative quantity. The product is going to be negative, and I'm being asked to compare that with 0. So 0 is always going to be greater than any negative number, right? So answer here is answer choice B. So it's a trick question. You could have also done arithmetically, but just try to observe how there is some logic employed in most of these questions. All right, let's look at question 12. R S J K. All right, S plus J. Okay, I can pick some numbers. Let me pick some basic numbers. So this is JK, and they have given me both axes. So J is, what is J? J is the distance from y-axis, correct? So this is some positive and this is some negative distance. So basically this is something like a 1 comma minus 1, right? I go 1 unit uh, on x-axis and I come down 1 minute from y-axis. I get 1 comma minus 1, and this is going to be minus 1 comma 1, something like minus 1 comma 1. Okay, the point here to note is this is going to be a negative number and this is going to be a negative number. Okay, whereas this is going to be a positive number and this is going to be a positive number. You don't have to pick minus 1, I mean 1 minus 1 minus 1 2. You could pick any numbers. They don't even have to be sort of related to each other. It could have been 5 by 7, this could have been 2 3, but they would always be like this. Correct, that's the point. Okay, so let me go with the easier case, minus 1 1. So what do I have to do here? S j, that is a positive number plus positive number, which is basically 1 plus 1 2 in this case, and r and k, which is this negative number and this negative number, minus 1 minus 1 minus 2. Okay, so again I'm getting this as addition of two positive numbers, right? S plus s and j are positive, and this is addition of two negative numbers, correct? uh, Basically this is going to be always negative, this is going to be always positive, something similar that we saw in the previous question also, and answer is always going to be A. That's the trick here. The trick here is to recognize that r and k will always be negative and s and j will always be positive. Okay, and also be careful with this, the exact term given s and j. S is the y coordinate here, j is the x coordinate here. Okay, uh, don't sort of mix up. I mean, don't add x coordinate of this and x coordinate of this versus y coordinate this and y coordinate of this. No, that's not what is asked. They're asking something very different. Okay, but again, the trick here is to realize the nature of coordinates. It's a very unique type of question I have seen so far. So I really like this one. Answer choice A. Okay, let's move on. Question 13, the greatest of the four fractions given. Okay, kind of weird fractions. I can do it by calculation. That would not be my first method, because then that I'm likely to make some error somewhere. Okay, the greatest of the four fractions, the sum of 0.325 and the least of the four fractions. Okay, so I think we'll have to find the greatest first and the least first. This part is fine. The sum of least plus 0.325, that is very easy to do. We'll have to first find the greatest and the least. Okay, how would you do that? Okay, I think I went ahead. Okay, how would I do that? Let me just get rid of this first. Okay, I need to get latest and okay. What I'm going to do is, see, if I want to compare sort of two fractions, let's say 5 by 8, 1 by 3, I can always do cross multiplication and figure out, right? But here then I'll have to do so many cross multiplication. I anyway want to find out the greatest and the least, right? So I'll have to compare all four together. So what I'll do is, easy way is, I'll multiply everyone by 10. Okay, all fractions by 10, so that they will still remain fractions, but the calculation is easy. 5 by 8, I don't want to do calculation, but here I think calculation is the easiest way to do. So these are the four numbers that I get, correct? I multiply by 10. See, the greatest and the least are still going to remain the same, because every number is multiplied by 10, so it doesn't matter. So, and I'm going to do rough calculation. Okay, so 50 by 8 is what? 50 by 8 is 6, 6 8s are 48, and remainder 2. Remainder 2 is 0.25 when the base is 8. Okay, so this I get 6.25. Okay, this was fairly easy. 10 by 3 we know 3.33. Okay, this here, okay, this is very easy. 30 by 10 is 3. Okay, so this is a whole number, right? And 40 by 7, 7 fives are 35, so remainder 5, so that becomes 50. 7 sevens are 49, and then 1. Okay, fine. uh, at least now I'm able to compare the two. Okay, so the least, I'm only interested in the least and the greatest, so let me just write the least is what? This is the least and this is the greatest. Okay, but note that this is not the number. Okay, then because we have multiplied everything by 10, the actual numbers are like this: 0.625, 0.33, 0.571, 0.3. These are the actual numbers. Okay, so what are they asking us? 0. Uh, the greatest of the numbers, so that is this. So this is 0.625, the sum of this number plus the least. So 0.300, that's this number, plus 0.325, that is the sum, 0.625. Okay, so here I am getting 0.625, and like magic, both are the numbers are same. Okay, that's where this number has to play that role. This number was, when they wrote the question, they calculated this number, and then they put it so that both of them will match. Okay, anyway, it doesn't matter how they thought. What we are thinking here is both the numbers are the same, so answer is going to be answer choice C. Okay, fairly interesting question. This was a trick you could use. I mean, you could have also done directly 5 by 8, but then this number, this, I thought this is useful because then you can filter out the least and the smallest and the greatest numbers more easily without getting confused. Okay. Question 14. If x is an integer and the remainder when 2x is divided by 4 is 0, okay, x is an integer, let's say 2, the remainder when 2x, let's say x is x and 2x, let's write out x is 2, 2x is 4, the remainder are divided by 4 becomes 0. Okay, so I think x is equal to 2 works. What other number could work? I need 2x to be divisible by 4, so that means 2x has to be of this form. Okay, like this. That means x has to be of this form. X has to be an even number basically. Any even number 2x is going to be divisible by 4. Okay, so these are the 4 cases. I think we have enough cases. Let's look at the question. The remainder when x is divided by 4. So the remainder is x is divided by 4 is here 2, 0, 2, 0. It could be 2 or it could be 0. That much I know. So in one case, when it is 2, I get answer as A. When it is 0, I get answer as C. Not able to determine one specific answer. So answer is going to be answer choice D. Okay. Figuring this out, what is the behavior of x and what is the behavior of 2x? I think that's the key here. Okay. Let's look at question 15. Let me again remove this. R, S, and T are radii of 3 circular regions that have areas capital R, capital S, and capital T. Okay. So there are 3 circles. The areas are R, S, and T, and the radii are R, S, and T respectively. Okay. R is equal to 2S. All right. So I think anyway, obviously I hadn't read it at the time. R is equal to 2S, S is equal to 2T. So let's say the actual figures are like this. T is small, double of that area is S, and double of that area is R. Okay. So what can I say about R and T? Because those are the terms that need to be compared. So if this is T, this is 2T, and this is 2S. So this is going to be R is going to be 4T. Correct? Okay, if R is equal to 4T, now let me write down the formula area of pi T square 4 times. Okay, pi R square is it. So this is T. Pi R square is equal to 4 T square pi. Pi gets cancelled. What do I get? R square is equal to 4 T square. Take the root, I get R is equal to 2T. So again, R is equal to 2T. Answer is going to be C. Right? Intuitively also you could have done it. How? You know that R is equal to 4T. That much you'll have to calculate, right? Looking at this. And if the area is 4 times the dimension, X direction or Y direction, the dimension has to be root of that. Correct? Because area is basically area is the square of the dimension. And the dimension is the root of the area. So the dimension of circle R is going to be 2 times, that means the square root of 4 times the dimension of uh, figure T. It could have been any figure, it could have been rectangle or anything, right? So this factor and this factor are related by our square roots and roots of each other, depending on how we are looking at it. Okay, so that's the concept. Without getting into the calculations, you could have done it that way also. But the answer here is C. Okay, let's look at the next set of questions. Question 16. If 2x plus 3y is equal to 15 and y is equal to 1, okay, y is equal to 1, so 3y is going to be 3. So basically I am told that 2x plus 3 is equal to not 12, 15. Okay, if 2x plus 3 is 15, So 2x is 12, x is equal to 2. So x is equal to 6. Okay, but they are not asking me 6, they are asking me 2x. Okay, so 2x is going to be 12. Answer choice B. Fairly straightforward question. As I keep mentioning, question 16 to 20 are sort of the most straightforward ones. If a question 17, if a small juice can contain 200 milliliters of juice, all right, a small juice can contains 200 milliliters of juice. How many liters of juice are there in a case containing 48 small cans? Okay, so 48 small cans into 200 milliliters. That is the total quantity of this case, and 1 liter is 1000 milliliters. Okay, so I have to find out everything in liters. So let's get everything in liters. So 48 into 200 milliliters is 1000 milliliter by 5, correct? 1000 milliliter. Why I'm writing in 1000? Because I need to get 1000 milliliter, which is 1 liter. So basically it's saying 48 into 1 by 5 liters. Okay, 40 into 1 by 5 liters is going to be 4 96 by 10, 9.6, right? 9.6. uh, all answers are in 96 only. Okay, so let me just verify. uh, Correct. Just be very careful, because sometimes you tend to do some silly mistake, and silly mistakes always happen when you don't expect them. That's why they are silly mistakes. So always be careful, and on the GRE you'll have enough time to verify. Okay, question 18. 32 by x minus 6 is equal to 2, then x is equal to y. Okay, so let me separate out x on one side. 32 by x is equal to, this minus 6 comes here, becomes plus 6, so it becomes 2 plus 6, 8. So what is x? X is 32 by 8, which is 4. Answer choice D. Okay. Okay, this is interesting. Basic arithmetic. This is 300. All right, so this is 300. This is 4. This is 5000. 5, 1, 2, 3, and this is 60. Okay. So if I arrange them properly and I add them, I get 5600. Sorry, 5364. Be careful. Okay, 5364, correct. So 5364. Answer choice E. All right, question 20. In the figure above, x is equal to what? Okay, I can see that there are these two lines, so this angle has to be the same, right? This is 90 degrees, this is also 90 degrees. So whatever is this angle plus 35 is 90. Let's say if this angle is y. Okay, so y plus 35 is 90. So y plus, this is going to be 35 in that case. 35 is 90, because here also y plus 35 has to be 90, correct? So if this is 35, what is x? It's going to be 180 minus 35, which is going to be 145. That's just D. Why am I saying this? Because again, this is on this line. Okay, so this angle plus this angle has to add up to 180. So I'm getting 145 as the answer. Right. So as I keep saying, this is sort of the easiest, most straightforward lot. Okay. I'm excited for the graph. Let's see. It doesn't look like a graph, looks more like a table. There are two tables. Okay. We'll see. Speed of winds in the US, miles per hour. Okay. There are certain stations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 stations. I don't know if that counting was useful or not, but they are given alphabetically. Okay, these are all places: Atlanta, Boston, Buffalo. Okay, fine. So in these stations they have calculated speed of winds up to and including 1967. Okay, till 1967, what was the average, what was the high? Okay, so let's say Atlanta, x number of uh, times they took this calculation. The highest that they found till 1967 was 70 miles per hour. The average uh, was 9.2. Every time they took the reading, the average of those readings was 9.2, and similarly like this. Okay, and this is same table up to and including 1979. Okay, So till 1979, they did the same calculation, and so the only difference here is that they have more 12 years of more data in this. Okay, the average was 9.1, the highest was 70. Okay, the highest was 70 here also. That means no higher speed was observed in Atlanta in next 12 years. Okay, what is the starting year? That's not given. Uh, I maybe that's not important. But basically, whenever they started, the average till 67 was found out to be this. The highest was found out to be this. Next 12 years also they continued to do the same. Average was found out to be this. The highest was found out to be this. Okay. Fine. So this table is okay. Speed and official designations of winds. Okay. So if the wind is less than 1 mile per hour, it's calm. If 1 to 3, it is light air, light breeze, gentle breeze, like that. And then it goes on increasing. Moderate breeze, fresh breeze, strong breeze, near gale, gale, strong gale, storm, violent storm, and hurricane. So I'm expecting questions like how many hurricanes were there in, let's say, I mean, not how many, was there a hurricane ever in, let's say, Pittsburgh? So Pittsburgh, the speed was never crossed 58. So there was always the maximum that they experienced was a storm. Okay, they never experienced a hurricane. That kind of calculation they might ask. Okay, all right, but let's move on. We don't know what they're going to ask, but I think we understood the tables. Let's look at the questions. Question 21 through 1967. That's been the first table. First table, 1967 column. Here I have to do something. Okay. Uh, through 1967. Okay. Now here the terminology through 1967 basically means all the time till 1967. That's the first column, sir. First set of readings. Through 1967 was the ratio of the highest to average wind speed in Boston. Okay. So 1967 highest to average Boston ratio. Okay, so this is Boston. Highest to average ratio is 65 by 13 is 5 is to 1. Okay, interesting numbers. Again, there is no point or anything. So 5 is to 1, answer choice A. Very straightforward if you collect, refer to the correct table. Okay. Question 22. For the three places whose average wind speed through 1979, now second table, I have to find out three places such that where the three highest. Okay. So what are the three highest average wind speeds in 1979? Let's find out that. Okay, then we will look at this. Always split the question so that it becomes easy for you. Let's find out 1979 three highest average speeds. Okay, 1979 average highest speeds. Okay, I see that most of them are single digits, so I'll concentrate only on the double digits because I want to find the highest. I get only these five double digits. Okay, within that also 35 is obviously the highest. Okay, so this goes as number one. Then I have 12.6, 12.3, and these are 10 point something. So I need highest three. Second highest is this, third highest is this. So this is second and this is third. Okay. All right. So Mount Washington, Boston, Buffalo. Let me just write it down. Mount Washington, Boston, Buffalo. All right. Now I'll read the question. For these three places where the average speed in 19 till 1979 was the highest three, approximately what was the average arithmetic mean of those wind speeds? Okay, so what was the average of these three? The three top speeds that we calculated. So the average would have been 35, the average of 35, 12.6, and 12.3. Okay, what is the sum of that? Is going to be something like 0.9. This is 24 plus 12 plus 12 is 24 plus 35, which is 59. So 59.9. Let's assume it was 3. Let's assume it to be 60 items. There are 3 items, so 60 by 3 is 20. Actually 19.99 something, but approximation is 20. Unit is miles per hour. The average is going to be 20 miles per hour, something like that. Okay, let's look at this. Okay, 20 miles per hour. Okay, why are they given 157, 151? Okay, those are like really off numbers. Are they mentioned here? 157. Okay, maybe even if you add them up, you don't you don't get that. I don't know. Okay. Yeah, this was a tricky one. If you add them up, you get 60, right? But they are asking for average, not the sum. So answer is going to be D. Okay. Anyway, most cases you must have observed that answers are fairly widespread. So approximations work. Okay, question 23. For how many of the places shown did the highest wind speed change from 67 to 69? So I need to compare the two tables and I need to find out how many times the average, highest. Okay, be careful what we are comparing. If there was a change in highest, I'm going to count that. If there is no change, no count. Okay. Uh, 70 70 no change, 65 65 no change, 91 91 no change, 60 60 no change, 49 49 no change, 56 56 no change, 73 73 no change, 132 132 no change. Okay, here I got one change, so that is 1, 231 231, 70 70, 73 109. Second change, 58 58, 71 71, 51 51, 78 78. Okay, did not find any more changes. There are only two changes, one in Montgomery, the other in Omaha. I don't need that information, but I'll still write down Montgomery, Omaha, and number of times there were speed changes. Okay. For which of the places shown was the absolute value of the difference between the average? Okay, this is a lot of information, quite a mouthful. Be careful when, especially in graph questions, what they are asking. Okay, so let me try to split it at an appropriate place. For which of the places? So I need a place. Okay. Out of these five, what is the place where something happens? Okay. So one thing I can theorize right now is that I only need to look at these five places. Maybe I don't need to look at the whole table because there are total 16, right? It's easier to find out something for five places than to find out something for 16 places. Okay, so I'm just going to look at this five information. For which of these following places was the absolute? What do I need? Absolute value of the difference. Okay, absolute value of the difference between two things. What are those things? Difference between average wind speed through 67 and average wind speed through 79. Okay, so I need to find out the absolute value of difference between the two averages. Okay, go to Boston. Okay, which is the first city station. Find out what was the absolute value of the difference between the two averages. Which two averages? These two averages. What was the difference here? Then what was the difference in second city? What was the difference in the third city? Like that, find out, and then uh, what was the greatest difference? Okay, that's what they're asking. Okay, fine. So I'll go to Boston and I'll find out the difference. It's easy to first write down all these values here for these five. Okay, so Boston was 13 12.6. Okay, 13 12.6. The difference is zero point 0.4. Okay, Chicago is, I probably don't need to write all this, I can just do it there, but I think it will be easier for you also to understand. Chicago is 12.2 12 point, sorry, 10.2 10.4, 10.2 10.4, so that difference is zero point 0.2. Mount Washington 35 35.6 35. Okay, 35 point 35.6 35, so the difference is zero point 0.6. Omaha San Diego, all right, Omaha is 11.1 10.8, 11.1 10.8, so difference is zero point 0.3, and San Diego is 6.5 6.7. Okay, 6.5 6.7, difference is 0.2. All right, what do I need? The difference to be greatest, which is here for Mount Washington. Okay, quite a bit of it's a straightforward question, but the language can be tricky. Okay, let's look at this question 25. The data infers that between December 31, 1967 and Jan 1st, 1980. Okay, now you need to observe that basically they are saying, referring to this period between when this thing has ended and this thing has ended. Okay, right. So at the end of 1967 till the end of 1979, something need to be found out. Which of the following can be true? Okay. Compare these two tables and tell me what happened between these two dates. Okay. There was an hurricane wind recorded in Omaha. Okay. What is hurricane? Let's find out. Hurricane is 74 and above. Did 74 and above wind speed happen in Omaha? Okay, let's say Omaha. Where is Omaha? Omaha. Did 74 something happen? Yes, it happened. Why? Because average earlier highest was 74. Now the highest is 109. That means at least once there was this 109 thing happened, which is characterized as hurricane. So yes, this is true. Okay. The average wind speed in Montgomery was 6.8. Okay, the average was 6.8 Montgomery. We'll find out. Montgomery earlier average was 6.9. The later average is 6.7. Uh, does that mean that the average was 6.8? That's a very trick question. It looks like the average was 6.8. No, actually, right? Or can we not decide? So I don't know when it is started. Maybe there were 100 entries made here. The average of that happened to be 6.9. How many entries were made here? I'm taking this 100 is also an assumption. Let's say if there were 100. How many were there for this average to be 6.7? If anything, I can say that on average between this date and this date, the wind speed has gone down. Okay, that means in these 12 years, the average, I'm not talking about any particular one, in this 12 years, the average winds have been flowing slightly less speed than till 1967. That much I can say. Okay, but again, that's an average. I mean, obviously there could be one wind that was recorded much higher, which is indeed the case here, because see, 60 to 72, there was a jump. There was the highest wind speed uh, could have been there, but I mean, we don't know how many were there, and just too many things we don't know, right? So we can't say with certainty was the average was 6.8. Also, average cannot have been 6.8 anyway. Another way to look at this is, see, earlier the average was 6.9. If the average of the new data was 6.8, right, then the overall average could not have been 6.7. Okay, what I'm saying is, let's say there were 100 wind speed notice, average was 6.9 till 1967. Then X number of recordings happened. The average there was 6.8. Then the overall average would be somewhere between these two only, right? It will have to be something greater than 6.8. It cannot be 6.7. Okay, so this is definitely false, right? Okay. Three, the wind speed in Chicago was never as high as 60 between the two tables. Okay, after 67, before 80. Okay, in Chicago, what was the wind speed? This top was 60, this top is also 60. Okay, so the highest recorded was the same, but does that mean that, so here let's say in one particular time, let's say 1960, okay, a wind speed of 60 was recorded, and in this year, in this period, let's say 1970, another instance happened where 60 was recorded. Okay, so this 60 and this 60 could actually refer to two different hurricanes. I don't know if those are hurricanes, uh, two different storms, let's say, right? One storm could have happened after 1967, or maybe this 60 and this 60 is referring to the same 1960 event. I don't know that. It is possible that nothing more than 60 happened in these 12 years, or it is also possible that something happened, but that was also 60. Okay, so I cannot really say whether the wind speed of 60 was recorded ever or not. I cannot say, right? So cannot be determined. The only thing I can determine to be true was answer choice 1, 1 only, right? Fairly tricky set, not from the calculation point of view or a graph point of view, but from logic point of view. Especially these three were pretty interesting to solve. Okay, let's look at question 26. Ricardo lives 4 kilometers due west of Pat's house. Okay, so let's say Pat lives here. Ricardo lives here 4 units. Okay, Anne lives 6 kilometers. Okay, everything is in kilometers, right? Anne lives 6 kilometers due north of Pat's house. So Anne lives here, which is 6. Okay, and 4 kilometers due west of David's house. Okay, Anne is 4 west to David. Okay, so this is 4. This is David. Okay, always read carefully. Anne is 4 kilometers west of David. All right. What is the straight line difference from Ricardo to David? Okay. So Ricardo to David, what is the straight line distance? Okay. All right. Okay. For us to calculate that, there are two ways. One is like a long way. You could find out this distance first, then you find out this distance first. But then how are you going to find out this distance? Okay. For that, you need to find out this distance. Okay. We don't know that. But anyway, we don't need that, because if you just make a small adjustment to this and draw it like this, okay, see, all the directions meet at 90 degrees, right? So this is going to be 90. That is understood. Okay, what is going to be this total? This to this is going to be this 4 plus this 4, right? So this is going to be 8. So essentially I'm talking about Ricardo here, David here. This is 8, and this point to R distance is 6 as given. Okay, and again we keep seeing this Pythagorean triplet of 6, 8 and 10. 6 square 36 plus 8 square 64, you get 100, root of that is 10, right? Classic GRE pattern, right? So the straight line difference between the two is going to be 10 kilometers, right? Fairly tricky in terms of visualization. I like this question actually. Okay, question 27, of the following which is most nearly equal to 2 by 3? Okay, again there are 5 fractions. They are asking me to calculate fractions. This is going to be a lot of calculation. Okay, I can do the fraction way. That's going to take a lot of calculation. Let me just find out if there is a pattern. Okay, so this is 3. I see that all the denominators are 3. So these 4 comparisons are going to be easy, because I can just multiply something. This 3 by 4 I can do in fractions. So I'm doing a hybrid method. Okay, let me compare all of them. 2 by 3 is equal to 0.66. Okay, so 3 by 4, the denominators are 3 and 4, so it's easier to do it fraction wise. So 3 by 4 is 0.75. Okay, uh, and what do I have to do, by the way? Which is most nearly equal. Okay, so the difference between these two is what? 0.6 and 0.7. Difference is 0.09. Okay, that's the difference. All right, the other calculations I'm going to do in fractions. Okay, because those are easier. 5 by 6 to be compared with 2 by 3, which basically is 4 by 6. Correct? So I write 2 by 3 as 4 by 6. I need to compare that with 5 by 6. The difference there comes out to be 1 by 6. Correct? Okay, same thing I do with 7 by 9. I compare 2 by 3 with that, which is basically multiply by 3 if I do, which is 6 by 9. Okay, 7 by 9 compared with 6 by 9, difference is 1 by 9, right? Okay, now I see some pattern. This is 1 by 6, this is 1 by 9. All right, 11 by 15, if I compare with 2 by 3, basically I have to multiply by 5. So I get 15 here, I get 10 here. The difference between these two is 11 by 15 minus 10 by 15. Rather, yeah, 11 by 15 minus 10 by 15. The difference here is going to be what? 1 by 15. Correct? Okay. And then we have 15 by 21. 15 by 21 compared with 2 by 3, which is basically multiply by 7. So 14 by 21. The difference here is going to be 15 by 21 minus 14 by 21 is going to be 1 by 20. Okay. So now out of these, I know that this is some number, smaller number is this, even smaller number is this, even smaller number is this. So now the difference is, let me eliminate these answer choices. Okay, these are gone. Okay, I need to find out the smallest, right? So this is 1 by 21, this is 0.09. Okay, let's get everything in fractions only. 1 by 21. Here the difference was 3 by 4 minus 2 by 3, which is 9 minus 8. Oh, here also I could have done fractions. Okay, but just that this would have become minus 12. So this is 1 by 12 and this is 1 by 21. Okay, again the winner is 1 by 21 only. Okay, I need the smallest, right? Okay, smallest as in I need the smallest difference, which is most nearly equal. That's another logic thing. Okay, most nearly equal basically means where the difference is smallest. So the difference is smallest in this only. Little bit of calculation. I think this set is a slightly more calculation intensive than most other sets. Okay, but yeah, last couple of questions were really interesting. Okay, let's look at question 28. If a certain object has been moving at the constant rate of x meters per minute, okay, x meters per minute, let's say, fine, I'll pick some number maybe. How many meters has the object moved in y seconds? Okay, so they are playing something with minutes and seconds, so it makes sense for me to say x is equal to 60. So it is moving at x 60 meters in 1 minute. In 1 minute, okay, that means 60 meters in 60 seconds. That means 1 meter in 1 second. Okay. If x was 60, let's assume x is equal to 60. Okay. Then how many meters has the object moved in y seconds? So in y seconds, it has moved y meters. Okay, it is moving 1 meter in 1 second. So answer has to be y. Uh, Answer has to be y. Where am I getting answer as y? If x is equal to 60, where am I getting answer as y? This is I mean, obviously you can do it with formula and everything, right? Uh, but this is an intuitive way. So I'm getting, if x is equal to 60, here this will get cancelled. I'll get y here. If x is equal to 60, I'm not going to get y as the answer here, okay, because y is in the denominator, right? Here also y is in the denominator. Here also y in the denominator. Here the answer is going to be 60 into 60 times y. I just need y. So this is out. The answer is answer choice E. You could do it conceptually also. So it is x meters per minute. That means x by 60 meters per second. There are y such seconds. So xy by 60. Directly also you could do. I just happen to pick numbers so that the possibility of error in difficult questions is less. All right. Question 29. Okay, there is some figure here. In the figure above, a circle is inscribed in the square. Okay, so this is a square, and also this diagonals in this. This is also a square. Okay, everything is 19. All right. Okay. If the square has side of 10, square side is 10. So that means this is 5, 5, 10. The radius is 5, diameter is 10, side of the square is 10. Okay, that's the story. Oh, not 10, 100. The square has side of length 100. So this is 50-50. Sorry. So this is 50-50. Then the perimeter of the square is approximately how much greater than the circumference of this. Okay, fine. What's the perimeter? Perimeter is going to be 4 times the side. So that's going to be 400. 400 is how much bigger than the circumference of the circle. Circumference of circle is 2 pi r. R here is 50. So 2 pi 50, basically 100 pi. What is the difference between this and this? 100 pi is 314, right? Pi is 3.14, so 100 pi is 314. What's the difference? 400 minus 314 is 86, approximately 86 units, square unit. Okay, 86. All right, last question, question 30. 1 month Mary used 1/6 of her monthly salary for car payment. So I'm going to assume some number that's divisible by 6. Let's say $600. So she had monthly salary was 600. 1/6 is equal to 100 of that for car payment she used, and 1/4 more than the car payment for rent. So rent was 1/4 more than the car payment. 1/4 more means 25% more. So rent was 125. Okay. What fraction of her monthly salary did she use for both? So for both she used 225 together. 225 she used out of her salary of 600. What was that fraction? Let's divide by 25. So 25 here you get 9. 25 here you get 24. 9 by 24. Let's divide by 3 now. So you get 3 by 8. So that's the fraction. Is there a 3 by 8 here? Yes, there is 3 by 8. Okay, so the answer is going to be answer choice B. All right, so that was it in this set. As I mentioned somewhere along the way, I found this to be a little more calculation intensive. There were a couple of fraction calculation kind of questions, fairly calculation intensive. I mean, you could have used different logics in that, but still, this was slightly more uh, computational than what we have seen so far in this series. So that was one thing. Some of the questions were little different. One question was something like 5,000 plus 300 plus 60 plus 4, something that was really a very basic. I wouldn't even say high school. It was a very fourth grader, third grader type of a question. So GRE sometimes surprises you with those kind of questions. There will be enough number of such sort of sitting duck kind of questions that you should definitely never get wrong. But yeah, I mean it's just a matter of luck. Sometimes you get them, sometimes you don't get them. In terms of the graph, I didn't find it to be very challenging, but yeah, there were some phrasings that required us to decode. Always try to split the graph questions, the text of the question, uh, so that you don't get overwhelmed with all that information. Sometimes they just tend to have too much information in that. If you split it, it just becomes so much easier for you. Okay. So yeah, so that was sort of the learning from this test. I hope, like I mentioned in the beginning, that you have solved those questions along the way rather than just watching the video. Hope you do that, and all the best in your preparation. I'll see you in another video.